Hello everyone, welcome to the Association of Ontario Land Surveyors webinar number 27, Centimetre Surveying with your smartphone. The presenter today will be Pat Hills, whom I'm sure most of you know from our AGMs and other events, who is the segment manager for geospatial business at Cansel. So today's webinar got really high registration numbers, 400 registrants as of this morning. So Pat, either you must be really popular or the topic is really popular or both. This webinar qualifies for one formal CPD hour, and it will be recorded and posted to GeoEd as all our previous webinars at www.geoed.ca. And you can find it under AOS free courses. So as I mentioned, this is a very well-attended webinar. It is actually the third most attended webinar among all the 27 webinars that we've ever had. So we have some members join us from our sister associations across Canada, and even some people apparently from Alaska, Arizona, and Colorado, or they picked their own province by mistake, maybe, or maybe they're there on vacation. So lots of people from Alberta, welcome. Some from BC, Manitoba, Newfoundland, Northwest Territories, Nova Scotia, PEI, Quebec, and Saskatchewan. So welcome everyone. So just to go over the usual technical details, especially for people who might be joining us for the first time, all the attendees are muted by default. You can type in your questions in the chat box or question box that you see, and they will be responded to at the end of the presentation. Only the admin, myself, can see the questions, but I will do my best to copy and paste them for everyone to see. If I don't get to do that in time, I will just read them out loud to Pat after the webinar. You can minimize or maximize your control box by pressing the orange arrow at the top left-hand corner of the control box. You can drag the border between the camera image and the slides in order to change their relative size on your screen. And as usual, a follow-up email will be sent with a link to a short survey 1 hour after the end of the webinar, so that we can receive your feedback and you guys can help us keep improving our webinars. With that, I will pass control of the screen to Pat. Okay, so he could continue with his presentation. Okay, Pat, we see the one with the speaker notes right now. Yeah, great. We can see full-size slides now.
Okay. Hello, everyone, and welcome to this webinar. Thanks for joining in. As Julie mentioned, I'm Pat Hills. I'm the segment manager for surveying and scanning business at Cansel, and this includes GPS and robotic portfolios as well as LiDAR scanning. I have been around for a very long time. I'm pretty sure I've met most of you from Ontario, and if I haven't, then shame on me. I see a lot of you joined from around Canada, and I don't know about the latest list. I didn't glance there, but it looks like we don't have New Brunswick represented. So the only province not represented today, but thanks for joining in. Blaine Martin, the Executive Director of the OS, has called on me from time to time over the years to present on technologies. I think because he trusts that I'm not going to hit you with an infomercial or a sales pitch. So in that spirit, I've always tried to keep this sort of agnostic in its tone and present in the spirit of education. So although the topic today I'm going to discuss with you is a Trimble solution, I think the overarching implications of collecting data with your smartphone will be of interest to you as professional surveyors. That said, I want to make clear from the beginning that if the primary function of your business, and I believe it is with surveyors, is to collect the position and collect a GPS position with centimeter accuracy every day, then the hardware solution that you're using today, whether it's Trimble, Leica, or Topcon, or Sokia, is the solution for you. So if, and we'll talk about it a little bit later in the applications, but if you are either an occasional user You want access to centimeter accuracy on an occasional function, or maybe you're a business owner of a survey company that wants to go out from time to time without a big capital outlay. Or if the function of your job is a positioning component of your job is to support your other main business, then this is a good solution as well. So there have been a number of things on the collision course over the years in our industry. So recreational consumer products have been bumping up against the survey world for years now. We see that all the time. You know, you see people putting together drones, and you know, people hear that, you know, we sell drones, Leica sells drones, Cansel sells drones, and it's something they see in popular media. So scanning applications that you can get for a few bucks on your iPhone, things like that. So the conversation with the mainstream recreational consumers has crossed over into our world these days. So it's led to very rich discussions with my colleagues around what this means to land surveying professionals. The other thing is that surveying and mapping, as we define them, are getting closer together as well. So what are we trying to define in a three-dimensional space, and what is the deliverable? What is the end use? Today we're going to talk about Catalyst, which is very much a mapping, customer and consumer-driven innovation. In my early career, I thought of mapping as submeter as opposed to centimeter, and also it's resource-based, or it's GIS-based, that sort of thing. So it's sort of a different use. They don't do a lot of layout and mapping, but now our mapping customers today are demanding centimeter and decimeter accuracy. So they're crowding up, their cheek to jowl with surveyors now on sites. Their workflow is quite different. How they represent their coordinates, how they represent their design afterwards, or the as-built, or whatever it is, the land, is quite different. But the accuracy they're requiring is more and more all the time. I can still tell, if you look over my shoulder here in our showroom, I can still tell a surveyor from a construction worker when they walk into our showroom or our store. I can tell an architect. I can tell they just all look different. They're all different walks of life, and mapping clients as well, especially if they're environmental or resource-based mapping customers. You know, they might arrive on a skateboard. They look a little more hip than we do. You know, the period facial hair and the skinny jeans and the iPhone. They might show up with might show up in a Safari or a Prius with a canoe on the roof. But these worlds are colliding, and so what we're talking about here today is a product that is very much driven by that customer sector that is going to develop sort of in the future. So let's talk about it a little bit, and we'll just start with a review of how we got to today. So 1994, thereabouts, we were using basin rover configurations and doing differential surveying. All right, we still use this method today in remote areas where we don't have cellular networks, or when we require that little extra accuracy. So fast forward to today, 2017, in most built-up areas, surveyors are using NRTK, or network RTK. So whether that's Cansel's CanNet network, or like a SmartNet, or Topcon and Sukia's TopNet, it's very much a rover-only universe we're living in today. Of course, all these networks are modeling and delivering the latest CSRS epoch directly to the rovers in the field via cellular networks. And we've been doing this since around 2004, 2005. So your correction that you've been receiving to mitigate errors inherent in GPS has to come from somewhere. In the picture on the left, it came from a mobile base station, and we still do that today. And in the picture on the right, it's coming from a network of permanent base stations that are strategically placed around Canada in major centers. Okay, mapping clients have always required corrections as well to mitigate errors. But their corrections have typically come from satellite-based correction services, so lower elevation L-band satellites that are geostationary. So unlike our GPS and GLONASS orbits that are 20,000 kilometers up, these are relatively low geostationary satellites, which, as you know, means that they don't change into your relative position. So these corrections are being broadcast from these geostationary satellites. Sorry, and then so the Catalyst system from Trimble is sort of based on that sort of delivery model as well. All right, so finding a solution for surveyors who periodically need accurate positioning. So manufacturers have identified a need over the years for a solution for users who periodically require accurate positioning. Like I said in the beginning of this webinar, so the positioning component of their job, unlike surveyors, is to support their primary function rather than being at the heart of it, as it is with everyone probably on this call today. So examples of this would be engineers doing inspections, field technicians, geotechnical, landscape architects, landscape contractors, builders, drain contractors, crop advisors. And we've got this last one here, survey company owner. So if you're in a company and you periodically want to go out into the field to do some checking, but you don't want to learn sort of a robust survey system software, and you just want to use your smartphone and go out and do some checks with an app that you're running, then this is where this sort of product is going. It's closing the gap between sort of the occasional user and the professional solution. Like I said earlier, the professionals requiring high accuracy year-round in all conditions every day really need a hardware solution, and the delivery model here is we call it an SaaS, which is a software as a solution, requires a monthly subscription that may be prohibitive, or that would be prohibitive to use 365 days a year. And if someone is going to be surveying that much, then we move them to a professional hardware solution with something like a CanNet subscription. And this sort of solution moves how you would quote on a job. So rather than having a capital purchase that you're paying monthly on, or maybe you've leased it, this could be allocated more towards an operating budget on a project, for instance. Smartphone platform has evolved into a universal tool. Okay, we all know that the smartphone has become a ubiquitous accessory in all walks of life. So we as technology providers have felt a tremendous pressure to incorporate tablets and smartphones into our measurement solutions. Okay, they're easy to use, they're affordable, they're always on us. So there's an argument to be made around how robust these devices are, and that's something else that differentiates a professional solution from an iPhone or an Android tablet or something like that. And we'll discuss that a little bit more later. But another word we hear a lot, and something that Trimble uses, is customers want to bring their own device. And the younger professionals coming out of university, they want to use tablets. They want to use smart tablets. They want to use smartphones. So there's pressure from manufacturers to develop solutions that allow users to bring their own devices into the field. This wouldn't have been possible, even 6-7 years ago. There's been a profound shift in the market space today in the processing power of a smartphone. So even when the iPhone came out, as you know, it wasn't positioned as a professional tool. BlackBerry users and iPhone users were very much different. BlackBerry users, and the BlackBerry was considered a professional tool, and the iPhone was not. It was more of a social media sort of lifestyle device. BlackBerry bet against the big data, big networks, and here's where we are today. So the processing power of these smartphones is such that we can develop apps to use in a professional sort of environment. So increased availability of a broad range of digital data services combined with smartphones simplifies the use of spatial data for professionals. Okay, the more we can take information and share among the stakeholders in a job, the more cohesive and collaborative our tasks become. Okay, there's fewer cost overruns, etc. If everyone's getting updates to job all the time in the cloud with alerts and notifications and all that kind of thing. Oops. Connectivity enabled by growth in cellular coverage and use of the cloud and SaaS-based solutions. So, like I said, software as service is what SaaS stands for, SaaS. Okay, and a lot of manufacturers of hardware and software are concentrating on connectivity and collaboration. Okay, in fact, they've been doing this for years. The question posed to us was, how do we collaborate more intelligently and seamlessly? How do we communicate changes and instructions in a frictionless fashion? So frictionless is a word that gets used a lot these days, and we, even at Cansel internally, keep this in mind with every new process that we implement. And when I'm describing a frictionless experience to someone, I use a couple of examples. So the 407 Express toll route is a frictionless experience. Okay, you're not pulling over and paying for a toll. You just drive. It knows when you get on the highway. It knows when you get off from your transponder. You get billed. It comes immediately off or automatically, if you'd like it to, off your Visa card. That's a frictionless experience. And I was in New Brunswick last week, and in contrast, I was using a toll road, and I didn't have $4 cash. I had to do a U-turn in the highway. I had to park illegally. I had to go into a building, pay with my Visa card to get a receipt, go back out, get into line, and hand that receipt to an attendant. Very much not frictionless. Okay, almost burst into flames. There was so much friction in that experience. So the whole world is going frictionless, and it just leads for more desirable or useful user experience. Another one would be something like national car rentals. Okay, you can show up now at National and pick any car in the lot and drive away. They've eliminated everything that people didn't like about renting a car. So that's just what we talk about when we say frictionless. And what we want to do is provide access to the right information anywhere, anytime, and enable new levels of field crew management and cross-organization collaboration. And we want to address the needs of a broader range of users by leveraging a smartphone to improve simplicity, ease of use, convenience, and affordability. For Catalyst, as a system, there are four components. It's a soft GNSS receiver service that I'm going to describe in detail here in a minute. Just a digital antenna, a subscription, and a smartphone. That's all it takes. So as far as the cost of the hardware, you're looking at sort of under $1,000. Not going to talk a lot about cost today. Like I said, I want to talk about the technology and how smartphones are entering into our professional lives. But you know, we're talking about an app for about $12 and a subscription and an antenna on a pole. So what is Catalyst? Software-defined GNSS receiver with a multi-frequency L1 and L2 antenna and multi-constellation. So for right now, it's just GPS and Galileo. So the way we describe soft GNSS, and I've got a receiver here. I can't see myself on the screen, but hopefully you can see me. This is an integrated GPS receiver. So it's got an L1, L2 antenna in it, and also inside we have an RTK processor. There's a differential processor. There's clock information. There's orbit information, and all that computes the position within the receiver. So if you imagine that processing piece, we've taken that out, and that's Catalyst, and we've embedded that processing piece into applications that run on your smartphone. Okay, so now the antenna is just the top part, and all it is delivering the raw L1, L2 to the processor, which sits in the app in Catalyst on the smartphone. So forget about the GPS receiver that's in your smartphone, that single frequency CA code receiver. It's not in play here at all. This is not a solution to make more robust that receiver in the smartphone. It dismisses that one altogether, and we've moved the processing now, because of the processing power in the smartphones, we moved it into the tablet and the smartphone. So it's designed for embedding into apps on mobile platforms. And right now it's Android only, just because it's easier to build apps and quicker in the Android platform. And then we can support this with a small, lightweight, high-performance dual-frequency antenna. I mean, I'm holding up a Trimble receiver here, but the same technology goes in, like a GS15 or a Topcon GR5. All the receivers work that way today. So it's very quick to connect. So at startup, we automatically select the best available. We don't automatically select. The app automatically selects the best available correction service based on location and subscription level. So there are 4 levels of subscription that give you basically four different accuracies. The first 2, meter and submeter, are using the RTX satellite system, which is an L-band, low elevation L-band correction service. And to get to decimeter and centimeter, we need the VRS network, so something like CanNet or VRS Now network, together with an RTX satellite correction service only. It's interesting. You may be interested to know that the fastest growing customer base that we have, and I know Topcon has as well, for RTK surveying or network RTK, is the farmers. So high-tech farming, they're using an RTX delivered correction only in some cases, because they don't need fast initialization time. So they don't care about 10 minutes in the morning to get an initialization, because they're not jumping in and out of the truck all the time, and they also don't worry about losing lock, because that 10 minutes starts over again because they're in the open field all day long. So they're using, in some cases, RTX only now. So, like I said earlier as well, there's this is basically a system that, think of it as a rental. It's you put in an operating cost versus a capital cost. So you download the app, purchase a low-cost antenna, pole and bracket, and subscribe to the level of service. Pay based on usage, and enables you to scale up and down based on your project, based on the accuracy you require, when you're working, where you're working, that sort of thing. So you just need the low-cost digital antenna. And I'll stress again that this is the occasional user. And we are limited as well by the environmental limitations of a smartphone. So we're talking probably 0 to 30 degrees Celsius. Don't use it in the rain. Those kind of limitations. So I'm just trying to manage your expectations here for a product like this. So why having an external antenna? So we need the external antenna to get the L1 L2 signals, right? So your smartphone only has the L1 CA code. It's probably accurate to about 3 meters at the best of times. And the current smartphones are single frequency only, right? And the antennas in those smartphones are designed for cost and not accuracy. So when you have a very, very small antenna, you can't incorporate things like a multipath ground plane. So you can't walk up against, you know, shiny buildings and walk underneath canopy and mitigate multipath on a smartphone. So that's why we need an antenna. And in those two pictures on the side there, we see one user is the person on the top there in a mapping environment with an antenna on her or his back. Can't tell who that is, but obviously they're not requiring centimeter accuracy. They're probably submeter because it's going to be as accurate as the position is coming to the pole in the backpack. And if you want to position on the ground, you sort of have to estimate the distance from the antenna to the ground. And the example in the bottom there, someone's using that in a more precise fashion with a pole and a level bubble and probably a fixed height 2-meter pole for more precise surveying. So how does this sort of system compare? When I first looked at this comparison matrix here, it had 3 or 4 times the number of columns in it. So I've sort of simplified it here, but it does successfully close the gap in positioning performance by significantly enhancing the mobile device's positioning accuracy. So if we're talking about the first column there is in the environment where we've got open, mixed, and harsh. The next one is smartphone GPS only. So so your smartphone walking around outside when you want to use that is accurate to about 3 meters, 2.2 meters in a mixed sort of open sky and little light canopy environment, and you know, closer to probably 4 or 5 meters in harsh environments. A system like this, like Catalyst, is in the submeter sort of offering, is 0.5 meter in an open sky, 0.8 meters. And you know, I've also eliminated the slides that show all the data behind this because we don't need to comb through all that. But there's all kinds of data sets to sort of get to these numbers. We don't need to look at that. But 0.8 meters, and then in harsh environments where there's more obstructions, probably a couple of meters. So Catalyst that is that someone's using on a network RTK solution can get down to a couple of centimeters. In open, mixed, and a couple of meters in a harsh environment. So I wanted to say, in case it doesn't come out in another slide here, is that this is still very much, as far as a user goes, mapping-based system because of the apps that it's compatible with. So we have an Esri app that will embrace this technology. We have a Teraflex app, which some of you might have used before, that embraces this technology. Very attribute-rich, no layout capability in it, because in a mapping environment, there's very few professionals doing layout and that kind of thing. So there isn't yet a survey application that runs this, that contains this engine. However, Trimble offers a software development kit, which Cansel has, and we'll see where that goes. So when we are authorized as to develop an application using Catalyst, we can develop our own. So we could develop them around certain aspects of surveying as well. If you were to Google this or to go on YouTube and look at applications where Catalyst is being used, there are quite a number of companies in the United States and Europe who have qualified as SDK developers because they have a unique function, whether it's resource management or it's some kind of engineering, facilities management, outdoors, crop management, that kind of thing, where they need to have more accurate positioning within their own app than an application to Trimble, and approval allows them to develop the application. And like I said earlier, it's only available right now in the Android platform, and it's only GPS. So you all remember when the limitations of GPS only. When we first started using it, of course, it was fantastic because we hadn't used GPS before. But then as soon as we integrated or introduced GLONASS, you know, so we had double the number of satellites, and we can work up against canopy. We can work up against, you know, buildings and that sort of thing. Initialization time, you know, dropped from a couple of minutes to 10 or 15 seconds. So right now it's GPS only. Pardon me, it's GPS and Galileo. It may be this September, this fall, more likely Q1 of 2018, that that GLONASS is introduced to this system as well. So we're probably several quarters out before there is a solution that satisfies the occasional use in a survey application. Okay, and the last column there is a GNSS hardware in a network environment with GPS and GLONASS. So that would be your Leica GS15, Topcon GR5, or the Trimble R10, something like that. So a robust professional survey solution in a network survey environment, or so a receiver that has GPS plus GLONASS. We're looking at a centimeter in open and probably 20 centimeters in mixed harsh environment, and then of course as soon as we're under heavy canopy, we're going to drop to that meter because we lose L2. Okay, so just a rough comparison and where this sort of fits in the market. I want to just talk about a couple of other limitations in something like this. Catalyst versus professional receivers. So Catalyst in a soft GNSS dual frequency environment. So we've got a GPS L1 and L2C. We've got Galileo, and we're using L-band for RTX corrections. Okay, we would call it a good performance. There is a longer initialization time, so you're not going to jump out of your truck and have a position in a few seconds. We're talking probably minutes. And when you lose lock, that time starts over again. Centimeter operation over shorter baselines, and it performs the best in open environments. So you really have to go back to the days when we used to do mission planning. We don't do that anymore, really. But is it really appropriate for this type of solution? And on the other side of the slide there, we got professional triple frequency receivers, and this would be all manufacturers: GPS L1, L2, L2E, L5, GLONASS, Galileo, Beidou, and L-band for RTX. And we would consider all of these receivers to give great performance, very rapid initialization time, and centimeter operation over longer baselines. Okay, so with the professional solutions you're using today, you're going to have a centimeter in the horizontal plus 1 part per million, so 1 millimeter for every kilometer you're away from the baseline. Probably half that accuracy in the vertical. And really, we can use them across all environments. We can use these receivers down to -20 now. Most data collectors that we're using are submersible, so very waterproof, very dustproof. So that's sort of the difference that we're looking at. So, and I sort of got ahead of myself there a little bit, but at a system level, you're looking at the limitations of the phones and the tablets and the operating temperature, obviously. Whatever your smartphone limitations are in the field. Battery life, you know, I haven't used Catalyst in a full day, but obviously that will come into play as well. There are external batteries that we can put on the pole to sort of mitigate that problem. And the upper temperature range is affected by the processor load. So upper and lower temperature range. And that is sort of dependent on the user device. So you won't see in any Trimble documentation, you know, how long you're going to be able to work in the field, because there are hundreds of different devices that you can take into the field with you. So the battery life is limited by the internal battery. So the typical, we've got an example here of a Samsung S5 is about 2 hours. It does vary with devices. If you're on Wi-Fi or cellular and the applications that you're running, how much of a burden they're putting on the processing power of your smartphone. And there is the option to address external batteries to extend that time. Rain and snow, again, are you going to take it into the field? It's up to you, based on the phone that you're carrying with you or the tablet you're carrying with you. Okay, but it does provide an option to meet several different sets of user requirements. Right on the left side, we got the professional positioning user. So we got an industrial grade quality, works in all weather, battery lasts all day. You're going to expect that to last for years, I know. It's the most productive, and it is a capital purchase. And this Catalyst solution is a positioning supported user. So I looked at this slideshow, although I've sort of adopted it for today. I looked at this first bullet point. It came from Trimble, and I saw prosumer. And I didn't even talk to them about it. I just think they're mashing up a couple of words there. So professional and consumer, I'm going to make that presumption. It's a new word that Trimble's created. So it's a prosumer grade quality. It works in normal weather conditions. I'm not sure what normal is because this slideshow was probably made in California. So we're anything but normal here in Canada. So you got to be wary of that, bringing a smartphone into the field. The battery lasts long enough to support the primary job, and there are external battery options. You're going to update this probably a lot more often because you probably only go a couple of years with your smartphone before a new one is available or you're eligible for a new smartphone. So but you're going to want to do that because every new major upgrade in smartphones comes with seriously higher processing power in the newer smartphones. So that's a big, from iPhone 5 to 6 was huge, and 6 to 7 as well. And this is primarily, if you compare these bottom bullet points, an operating expense compared to a capital purchase. So that's just something to keep in mind as well. Okay, so in summary, this is a new receiver in software solution. So remember that what you've got on the pole in this picture here is just an L1, L2 antenna. You're going to need a cable going down that pole to your smartphone running the app that has the embedded Catalyst software receiver in software in the bring your own device in your BYOD, whichever one you're using. It enables positioning on demand services. So if you're a professional who owns a surveying company and it's been 10 years since you were in the field, this might be something that you, because you've spent less than $1,000 on the hardware, you don't have to look at it every day and think, boy, how am I going to make some money out of that thing? You don't have to. Right now to use it, for a couple of months even, you're going to need a subscription to RTX Catalyst and an RTK or CanNet style subscription. So the subscription is probably twice the cost, just to sort of rent the app, if you will. It does deliver unprecedented ease of use for sub-meter positioning globally. So that is very inexpensive. So we're talking probably $100 a month if you just need sub-meter accuracy. And so that's up to you to sort of, if you have a division of your business that is sort of has a mapping lean to it, then this would be a solution for those professionals in your company. It enables the users in your organization to sort of a self-service. It's not going to require any support. It's not going to require really any of the servicing, for instance, that you require with your hardware. So it's very much, you've got your own device, you've got this one-time hardware cost and an app that's cost you $12, and the subscription that lights up the service when you need it for as long as you need it. Okay, is the Catalyst for a host of new applications for high accuracy GNSS. So enabled through your software development kit for the app developer community. So that's sort of a question, that last that last bullet point. But I think since we've got an engine or a solution here that can be embedded in apps, then it opens up a big market and lots of opportunity for this type of solution to grow. So that's my last slide. Some of you may have questions. I know there's several hundred people on the line here. I'm not sure we can get through, but I am Pat Hills from Cansel. You can find me on LinkedIn if you have any questions that you'd like to take offline. I want to thank you all for joining, and I'll turn this over to Julia right now, and have an accurate day.